Physics is lovely. Physics is wonderful. Physics is useful. Charging is our topic. Either friction or induction. How does electrons move in those? So let us now unravel these two. Hi guys! Welcome to another episode of the subject that every student fears of. P4, P5, Physics! For today's lesson, we are going to discuss charging, the processes of charging. Again, I am your amazing chemist slash physicist for this episode. Come on, join me in understanding different processes in charging. Moving on to our first experiment, it is the charging by friction. It is the result when two objects are rubbed together. Those materials can either be positively charged or negatively charged. And how will we know whether those objects will be negatively charged or positively charged? Let me introduce you to triboelectric series chart. In that chart, there is a positive charge at the upper portion and negative charge at the bottom part of it. The positive charge or the upper portion states the objects that has the capability or tendency to lose electrons when rubbed at the objects below it. For example, in this experiment needs straws, bottle, this is not sponsored, bench, backhand man, and also wool cloth or simply wool. So in here, our first step is to rub the straw and the wool together. In this, we can know that this wool will be positively charged and this plastic straw will be negatively charged basing from the triboelectric series. This wool is at the upper portion of the triboelectric series and this plastic straw is at the bottom part or lower part of the triboelectric series chart. So let us rub. Now we are done rubbing this straw. We will now rub another straw in this wool. We are done with the second one. Now, I have a question. If these two are negatively charged or has the same charge, what do you think the force will be? Will it be repulsive or attractive? If your answer is repulsive force, you're correct. Remember, same charges repel and opposite attracts. Remember that same charges repel, opposite charges attract. So in here, we will have repulsive force. Let us see if this will really have a repulsive force. See, that's the magic. So these two will have a repulsive force. If these two will have a repulsive force, what if this wool cloth will be put near the plastic straw, wherein they have opposite charges? This one is positive and this one is negative. What do you think will happen? Attractive force, very good. So now, let us try. See, they have a repulsive force since this has positive charge and this straw has negative charge. Remember, same repel, opposite attract. Moving on to our next experiment. This is our second experiment. This experiment will focus in charging by induction. Can you believe that a neutral body can be charged without physical contact with a charged body? That's possible by charging by induction. So in this experiment, what we need is an electroscope. An electroscope has copper wire, a container with lid, and the lid has a hole in it, and also some foil inside. Two small pieces of foil inside where I already inputted here, like this. And we will close this, and this is our electroscope. We also need some ruler and paper. So our first step is to rub this ruler here in the paper. So basing from triboelectric series, we can say that this ruler, plastic ruler, will be negatively charged and this paper will be positively charged. For this paper is at the positive part of the triboelectric series chart and this plastic ruler is at the negative side of the triboelectric series chart. So let us now rub this ruler here in the paper. Now, we are done rubbing. So let us now put this ruler on top of the copper wire. See, that's the magic in our second experiment. So as you have seen a while ago, the two pieces of foil move away from one another. How does that happen? So according to charging by induction, as you put a charged body near a neutral body, that will cause movements in this neutral body. So that is what happened in this experiment. This negatively charged plastic ruler was put near this neutrally charged body. So this means that they have equal electrons and protons in this system. So this negatively charged plastic ruler, as we put this near, the electrons will repel to this plastic ruler since this is negatively charged, remember. So as the electrons repel, they move down to the foil, causing the foil to move away from one another since the foil couldn't carry a lot of electrons. Since most of the electrons in this system went down because of this plastic ruler that is negatively charged. They repel the electrons, moving them the bottom part or in the foil. So that caused the movement in the foil. See, in charging by induction, a neutral body could do some movement or be charged by this negatively charged body or any charged body. But as you have seen a while ago also, that as I put my finger on the copper wire, suddenly the two foil went back, but not to its original position. Why? My fingers already acquired some electrons, so they did not go back to their original position. So that is the experiment. That is the explanation to this experiment. That explains charging by induction. That also explains our first experiment. These materials are initially neutral body. However, as we rub these two together, they acquired their charges. As we have proved in the first experiment that this became negatively charged as they repel one another, and this became positively charged and they attract one another, that simply proves that our experiments work. And this implies that triboelectric series chart really plays a vital role in these two experiments. So I hope you have learned a lot in this charging processes. Let us discuss the last charging process in the next episode. Once again, I am your LJ Amazing chemist / physicist. See you on our next episode.